Hello class, these are our notes for section 2.1, planning a pizza party. So first we're talking about a mathematical model. So a model is some kind of mathematical representation. So let's write mathematical representation. And when we say representation, let's go ahead and define that could be an expression. It could be an equation, or it could be an inequality. That is used to describe quantities and their relationships in real life situations. So these again are mathematical representation that's used to describe quantities and their relationships in real life situations. So we also have to talk about constraints. A constraint is something that limits what is possible or reasonable. Or reasonable in a situation. So thinking about your pizza party, a constraint would be that we don't have an unlimited amount of money to spend, right? So it might be that the money that you spend needs to be like less than $200. Another constraint would be that the party, maybe in order to have the pizza party that day, you need to have at least 10 students present. Or maybe something about the number of students in the class being less than 30. So those would be constraints. So the mathematical model would be maybe looking at how much it costs per pizza times how many people they are. So you're using math to kind of model what the cost is per person. So those are just some ideas about how those words are used. So we've got mathematical modeling, which means you're going to be using variables and numbers to represent a situation. And then constraints are going to have limits on that, where maybe you have a limit to your budget or to the amount of people or something. So we're going to look at this example. And we're going to pretend that our class is throwing a pizza party at the end of the quarter. The party budget is $150. So this right here, that's going to give us a kind of constraint, isn't it? Because we can't spend an unlimited amount of money. Great Alaska Pizza Company is giving us a discount on pizzas, $9 per cheese pizza and $10 per pepperoni pizza. Write an inequality that describes how many C cheese and P pepperoni pizzas the class can buy given the constraints. So other constraints here would be how much money it costs for each kind of pizza, right? And then if we think about modeling, well, we've got a variable for cheese pizzas. We've got a variable for P pepperoni pizzas. So let's think about how to put all of this together. So if I'm looking for my number of cheese, actually I don't want to say number of cheese pizzas. I want to think about this in terms of cost. So if I'm thinking about my cost for cheese pizzas, I'm going to have to take and I'm going to have to multiply how much per pizza times how many I'm buying. So if I buy one pizza, I would do 9 times 1. If I buy 2 pizzas, I would do 9 times 2. So I'm going to have to multiply the amount of money per pizza times how many I have, which is C. So when I look at my cost for cheese pizzas, that's going to be 9C. Now if I think about my cost for pepperoni pizzas, it's going to be something similar. So I know that each pepperoni pizza is going to cost me $10. So if I buy one pepperoni pizza, it's going to be $10. If I buy two pepperoni pizzas, well, 2 times 10 would be $20. If I want to buy three pepperoni pizzas, well, 3 times 10 would be $30. So again, I'm multiplying the price per pepperoni pizza times how many I have, but I don't have one or two or three. I have P pepperoni pizzas. So when I want to write an expression using that constraint, so the cost per pepperoni pizza is considered a constraint, I'm going to be writing 10p. So when I look at my total cost, I am looking at my cheese pizzas and my pepperoni pizzas together. So when I'm looking at my total cost, I would have to say 9c plus 10p. Now, my last thing that I need to worry about here is my constraint. The party budget is $150. So that means I could spend $150. It means I could spend $140. It means I could spend, oops, totally spelled that word wrong. I could spend $149.50. I realize these are whole dollar amounts, but it could be really close to 150, right? But I cannot spend something like $160. That's not possible. That's beyond my budget. So we're going to use an inequality for this. We're going to say that the amount our total cost is, so this is our total cost right here, is going to have to be less than or equal to $150. So that's what we mean by a math model. So my math model is 9c plus 10p is less than or equal to 150. So that's how I would write that inequality. So for your last step here, in our last example, we're just doing some matching. So let's go ahead and read through this. To support the American Foundation for Suicide Prevention, Service High School's Yana Club, that's You Are Not Alone, is holding a fundraiser. They're asking for donations of any amount, no matter how small or large. Their goal is to reach T dollars. So T dollars is the amount of money we want to have. Okay, there are N students in the school. Match each quantity to an expression, equation, or inequality that describes it. So we can imagine Yana holding this big fundraiser. I don't know what they're selling. Maybe they're just selling baked goods, right? So you could go buy a brownie, you could buy a cookie, and they're just saying, give us a donation. They're not even telling you how much you have to pay. So Yana's trying to reach T dollars. So maybe it's $2,000, maybe it's $5,000, maybe it's only $100. That's what they're trying to reach. And there are N students in the school. So we've got this total, that's our goal. And we've got N for our number of students. So they're not giving us any numbers on this. So that's going to be our job. It's going to be to translate some things and then do some matching. So A is saying the amount the club would have if every student donated 20 cents. So let's think about what's going on there. So if we talk about students, that's not my goal total amount of money, that's N. And it's 20 cents, which is 0.20 per each student. So per really means I'm going to be multiplying there, doesn't it? So 20 cents for one student, 20 cents times 2 for 2 students, 20 cents times 3 for 3 students. So we're going to match that to number 2 here, which says 0.2n. The amount the club would still need to raise to reach its goal if each student donated 75 cents. So that means each student, so now my N students are donating 75 cents, but I want to know how much left. So if we look at taking how much I need total, and then I want to subtract what I've raised. So I'm going to be subtracting the amount from each student. So my total is the amount I want raised, and I want to figure out how much I would still need to raise. So how much left I have to raise if I subtract that amount that we raised from students. So that's going to be number 3 here, where I'm subtracting 0.75n. So I think that's really tricky. When we're trying to figure out how much is left, well, we have to take T, the amount we want, minus how much we've raised so far. So maybe that's 75 cents per student. Maybe that's $100, right? So to figure out how much I still have to raise, I would have to do T minus the amount I already have. For our last one, the amount that the club would have if they reached 3/4 of their goal. So when I see 3/4 of their goal. In my head, what I can think about doing is replacing that of their goal. That's really going to be like that letter T. And of and math means times. So this means times. So 3/4 times T, which is just going to be 3/4 T, which is the last one that we have left. So I hope going through these notes helped you out. Please make sure that you ask questions in class.